Hello there. Today we're going to be answering this problem. How many 7-letter words are there with no repeating letters so that the letters are in alphabetical order and the fourth letter is a Q? Now, this is kind of an interesting problem actually. So first of all, let's kind of draw a quote-unquote picture of our situation. So we're going to have a 7-letter word, so 1, 2, 3, 4, 5, 6, 7. So we have 7 letters, and the fourth letter has to be a Q. Okay, so now we need to figure out what letters to put on the left side of the Q and the right side of the Q, and recall that they have to be in alphabetical order. So the first thing we're going to do is we're going to do the right side first. So okay, so if all letters have to be in alphabetical order, what letters can be on the right side of the Q? Well, if we go through alphabet A, B, C, D, blah, 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 Q, R, S, T, U, V, W, X, Y, and Z. So those are the values that can go to the right of the Q. And we need to take 3 of them and make sure they're put in there in order. So we can turn this into a little bit of a word problem with O's and X's again. So we can do, let's say, randomly choosing, say, O is an S, V, and an X. And then so all of the others get X's. Now this bottom line here, if a letter is given an O, then it's that's gonna designate that those letters will be in our 7-letter word. If they got an X, then they won't. So, and the order in which they're put into the word is just in the order reading from the left O to the right O. So in this case, the last 4 digits of the word would be Q, S, V, and X. So here, we can actually figure out the number of ways that we can put 3 letters there in order by figuring out how many ways there are to put these O's and X's in this order. So we can do that by taking a look at our X's and O's here and saying that, well, there are 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 factorial different ways to arrange these as the O's and X's if the X's and O's, if the different X's were distinguishable and the O's were distinguishable, but they're not. So just like any other combinatorial question, we have to divide by the number of O's in there and by the number of X's. So the number of ways in which we can put 3 O's in there, indicating which letters will go in our 7-letter word, are 9 factorial divided by 3 factorial times 6 factorial. So that will be that. So now that is the right-hand side. Now the left-hand side is very similar. And I'll just choose, let's go with red. So on the red-hand side, we have the letters A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q. Well, don't have Q there because it's already in the center. So here we have 16 letters to choose from in a similar situation. So we could even have like an O, X, O, 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 X, O, 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 O. So in this case here, let's put that as an X there. So in this case here, we're gonna have the for simplicity's sake, I'm gonna rewrite that just to keep everything consistent. So we're gonna say O, X, O, O, X, 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 X. So here on the left-hand side in the red, this means that our 7-letter word is going to have an A, a C, and an F. Okay? So here, just like on the other side, so we have 16 factorial different ways to arrange the O's and X's if the X's were distinguishable and the O's were distinguishable, but they're not. So we have to divide by 3 factorial to factor out the different ways to arrange the 3 O's, and 13 factorial to arrange the different X's. Now in order to get our answer, we just use the multiplication rule. So there are 16 factorial over 3 factorial, 13 factorial ways of choosing the first 3 letters, and 9 factorial over 3 factorial, 6 factorial different ways of choosing the last 3 letters. So the answer is going to equal 16 factorial over 3 factorial, 13 factorial times 9 factorial over 3 factorial, 6 factorial. And the answer you'll get there, if you do the calculation, will be 47,040 7-letter words with no repeating letters, so that the letters are in alphabetical order and the 4th letter is a Q.